Hello, and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook, and we're going to go over today's video instructional of inertia. So a lot of us might have heard this concept of inertia or moments of inertia, but what is inertia? Inertia was talked about as this idea of how mass wants to resist change. So a very famous line that talks about inertia is, an object at rest will want to stay at rest unless acted on by an outside force. Same thing, an object in motion will want to stay in motion unless acted on by an outside force. So how do we see this concept in our everyday life? Well, if you go to another video presentation we do a tablecloth pull that is very similar to what you will see on most movies of where they just pull a tablecloth out on a table and all the dishes remain perfectly still. The other idea that you might have seen is people playing giant Jenga. And they might have all these different pieces, and what they'll do is that they'll quickly hit that piece and it'll jut out and all the pieces above it will just fall straight down. This is a very clear-cut example of inertia, because the only piece that got felt was the one that was being hit. It had an outside force acting on it, and it moved out of the way. Now the rest of the items didn't feel that force, but they no longer were supported upwards, and they just fell downwards. Now, if you're thinking to yourself, well, Corey, why doesn't that work when you just push it a little bit? And that's because the force decreases on the object. As the force decreases, that coefficient of friction between the objects is static friction, and it's actually really big. Whereas or relatively big in that sense. But once you increase that speed, you're going to also overcome the static friction and go to a kinetic friction, which is less. So now you have less frictional force acting on the objects above and below. So that greater the speed, the less time or that impulse decreases for the other objects to experience what's going on to the object being acted on. So that's how all of a sudden all the blocks are able just to go down. This might be useful when you're playing Jenga in the future. So my hope is to recreate that Jenga moment, only I'm going to be using a ruler stick or a meter stick in this sense. It's a meter stick. And these tower of bricks. In these cases are just plastic kind of bricks that we kind of made here. And what I'm going to do first is I'm going to try to say if I can get this bottom piece out without making the rest of the pieces fall over. So the trick with this is to keep this meter stick along the plane of the table. So I'm almost going to be trying to push downwards to make sure that I'm only hitting one brick and not two. So as you can see there, I successfully got one brick out without making the rest of the tower fall over. Let's try one last time and see if we can do it. Boom. And I got two bricks out with that one swipe. So as we can see that this moment of inertia and that concept of that force being applied to only the two objects, overcoming the static friction, allows me to remove objects without affecting the others because of that non-existent outside force from the top and the bottom, but that existing force that's acting on these two objects due to the meter stick. Well, thank you for your time and for watching this demonstration, and have a wonderful day.